to work on those dreaded application problems for our SOH CAH TOA problems. So, what we should look at here. Here's a picture. All we have to do is literally draw a picture. So, I'm going to draw a flag here. Hopefully draw it in something that you can see. There's a flagpole with a little flag on it if you prefer. Maybe even give it a little U. Now, what we have here, with this flagpole, it says it's 45 feet tall, and it casts a shadow that's 28 feet in length. Assuming we're not in Pisa, we have a right triangle that's been formed here, and that's kind of what our little triangle here should look like. They want to find the angle of elevation. Elevation angle means I'm looking up, so that means that's this angle right down here. So what we should look for is a trig function that we can make here. The trig function comes from the angle. So based on this angle, I have this side which is opposite, and I have this side which is adjacent. So that in terms of our SOH CAH TOA, we're going to have opposite and adjacent. So we have tangent. Always take tangent of an angle. My angle, I don't know it, so I'm going to call it theta, equals opposite, which is 45, over adjacent, which is 28. Now, I'm finding an angle. That's what I need to do. Anytime I'm finding an angle, that's when I need to take the inverse, not sine, the inverse trig function. In this case, the inverse tangent of both sides. So that means that my answer is going to be whatever the inverse tangent of 45 over 28 is. And when you plug that into your calculator, if you're in degree mode, you should get 58.11 degrees. Okay, let's look at another one. Jack is standing 600 feet from the base of a hill. So I'll say, like, here's the hill, if I'm drawing it. Here's, there's a hill, cool. And here's Jack. Jack says hi. He needs to know how high is the hill. Maybe Jill's up here at the top of the hill. So if he's this far away from the hill, again, here's my right triangle I'm kind of forming. He's 600 feet from that hill, and we know this angle of elevation is 34 degrees. What do I want to know? I want to know how high the hill is. That's this height, this vertical height. So I'm going to call that my x. So again, based on this angle, what trig function do I have? I have opposite and adjacent again. Most of the time I will end up with a tangent. Not always, but that's pretty much the norm here. Now, tangent of what? Of my angle. I know what my angle is. It's 34 degrees. And it equals opposite over adjacent. Now, when I see my x up high, that's how I know to multiply. It's like I'm multiplying both sides by this thing on the bottom, 600. So that means that my answer, x, is going to equal 600 times tangent of 34 degrees. And when I plug that in my calculator, I should get as my answer 404.7 feet. Alright, those ones shouldn't be too bad. Now these ones end up being what I call two triangle problems, and here's why. If I'm drawing this, so I have, say, a guy at the top of a overlook. This overlook, it says here, is 60 feet high. So this is 60 feet. He looks and sees a campsite down here, and he sees, let's see if I can draw a good grizzly bear and not make it look like a spider with a big belly. Close enough, I guess. So, he looks down and sees the campsite. He looks down and sees the bear. The angle of depression, looking down, that means it's this angle up here. To the bear is 18 degrees, and to the campsite is 27 degrees. We want to know how far apart the bear and the campsite are from each other. Well, what I'm going to do is I can kind of ignore this half of the triangle, and I can look just at this triangle over here, and I can find this distance using my trig functions. Same way I can find a distance over here to find an x value and a y value, two different values. And then I can see, well, if it's set up like this, if I just add those two values together, I can find out how far apart they are. So what I really need to do is I need to find two different answers. So for this first triangle, which I'm going to kind of highlight here in pink, I'm going to have the tangent of my angle, 27 degrees up there, will equal the opposite x over the adjacent 60. So that means x will equal 60 times tangent of 27 degrees, which is about 30.57, I should keep my units here, of feet. Now I have this other triangle, which I'll mark here in green, and it's the same setup, except now I have an 18-degree angle, and this is going to help me find y over 60. So that means y will equal 60 times tangent of 18 degrees, which will give me an answer when I plug that into my calculator of like 19.49 feet, depending on where you round. Now, to find two different answers. If they're on opposite sides, all I'm going to do is add, like I said here, my x and my y value. When I need to find them on the same side, I'm going to subtract my answers, my x and y answers. And then I'll get my answer there, which is about 11.08. So those are your two answers. If it's opposite, you add your two values. If it's the same, you subtract your two values. Here's another example. I might say pause the video, see if you can draw this picture, and see if you can find the two answers being on the same side and on opposite sides. Alright, so let's try to draw a very bad lighthouse here. I suppose we have an observation deck on the top of the lighthouse, something like this. I know I can draw boats decently well, boats, boats, boats. There's one boat, there's another boat. What I should be looking for is this lighthouse here is going to be looking down. My angles are 21 degrees and 25 degrees, and I need to know my distances. So I'm going to call this one x, this one y. That way I can find two different answers. Let's start with, let's find this blue triangle first. I guess I should have also said here, I need to know how high the lighthouse was. It was 200 feet. So starting with the blue triangle over here, I'm going to have, again, it's tangent of this angle because it's opposite over adjacent. So tangent of 21 degrees will equal opposite over adjacent. It's up high, so I multiply. So 200 tangent of 21 degrees is equal to x. So that means I should get an answer of about 76.77 feet. I'll do the same thing for this other triangle, which I'll put here kind of in reddish pinkish. This one's going to be tangent of 25 degrees now, will equal the opposite, which is y, over my adjacent, which is 200. So that means it's up high again, my variable is, so I'm going to multiply 200 times tangent of 25. So I'll get for an answer here, when I type that into my calculator, of 93.26 feet. So again, find my value first for A. If they're on if they're on the same side, I'm going to subtract. And if they're on opposite sides, I'm going to add. So there are my two answers. If it's the same side, 16.48, and opposite sides, about 170.04.